welcome to my channel, and here we are going to solve this problem as we are instructed here that figure 3 shows an irregular pentagon PQRST with diagonals SQ and RT as 270 respectively. So this is diagram that is being talked about. Then question A says we should draw full size A Roman figure 1 the given pentagon, A Roman figure 2 a square equal in area with the pentagon. Then question B says that we should measure and state diagonal of the square drawn in 4A Roman figure 1. Okay, so looking at this diagram, this irregular pentagon, the dimensions are large. Okay, and what I'm going to do is that I'm going to draw half size of this figure. That means I'm going to divide each dimension by 2. Though we are asked to draw full size, so I'm taking that into consideration. But if this happens in exam, what I will just do after I do my construction, I'm going to state the scale that I used. I will state the scale that I used on the paper after I'm done with my work. That means I'm using a scale of 1:2. The reason why I'm going to draw half size, despite the fact that we are asked to draw full size, is that the compass that I'm using is small, so I cannot use it to take that diagonal of 200 millimeters, which is 20 centimeters on my ruler. So I can't, it can't be long enough to take such a distance. So what I will do is that I will divide each dimension by 2, then I will draw the half size. Then after I'm done with my drawing, I will state the scale that I use in my drawing. So that is 1:2. So that will not make them to penalize me. So they will not penalize me as long as I state the scale that I used. Okay, so let's go and look at how this work can be done. We are going to construct a square that will be equal in area to this given irregular pentagon. So let's start. So the first thing that we need to do is to draw a horizontal line. So horizontal line. So we draw horizontal line, so like this. Okay, so we draw horizontal line, so like this. Then I'm going to take a measurement. So as we have here, let's talk about the dimensions. So SR is 96, ST is 60, and then we have TP to be 140, PQ is 140, and QR is 120. So I will divide each dimension by 2. So we are starting with SR or RS. So 96 by 2, that will give us 48 millimeters. So I'm going to start from here. So this is the first point. So then I will take 48 millimeters away from that. This is 48 millimeters. So at this point I have S here. This is point S, and this is point R. Okay. Alright, so we have this. So the next thing that I'm going to do is that I will take my compass. So and then so SQ is 200. So instead of 200, I will take 100 millimeters. So which is equal to 10 centimeters on my ruler. So I will take it like this. So this is 100 millimeters. So putting the pinpoint at S here, I will draw an arc like this. So then we also have that RT is 70. Instead of 70, I will take 35 millimeters. So this is 35 millimeters here. So then putting the pinpoint on my compass at R here, so I will draw an arc here like this. Okay, now going on, we move on to get our ST and to get point T and point Q. So QR is 120. Instead of 120, I will take 60 millimeters. I will take 60 millimeters. So putting a pinpoint at R here, then I will make an arc here. So this point here, this point is point Q. So here I have point Q here like this. So then ST is 60. So instead of 60, I will take 30. So I'll take 30 millimeters. So this is 30 millimeters. So I put the point of my compass at S here. Then I'll make an arc here. So this is point T here. So here is point T. Okay. So now, So to get point Q, so to get point P, so the next is to get point P. So we are told that PQ and PT is 140 each. So instead of 140, I will take 70. So this is 70 millimeters here. So then putting a point my compass at T here. So I will make an arc here. Then putting a pinpoint at Q here. So I make an arc here. So this point is point P. So here we have P here. So this is point P. So I'm going to join them together. So I will join. So we have ST. So we join ST together like this. Then PT. So I will join them together like this. Then I will join PQ together. So I will join PQ together. So this is PQ. Okay, then I will now join QR together to get the given pentagon. So this is it. Okay, so this is the given pentagon. So we have constructed the given pentagon based on dimensions that we are given. But do not forget, in my own drawing, I'm drawing half size instead of full size that we are asked to construct. I divided each dimension by 2, and I've said that if this happens in the exam, this is what I will do because of the size of my compass. So at the end of my work, I will state the scale that I used, which is 1:2. Now let's go on and do what we are asked to do. We are asked to construct a square that will be equal in area to this given irregular pentagon. But before I construct the square, I need to do something. So I need to construct a triangle that will be equal in area to this pentagon. I will construct a triangle that will be equal in area to this irregular pentagon. So we need to do that. Now, how do we construct a triangle that is equal in area to this pentagon? So it goes as follows. So what you need to do first is to connect PR together with a straight line. Connect it, PR together with a straight line. Then we are going to draw a line. So a line at this point Q. So and to touch this SR extended, and that line will be parallel to this line PR. So how do we do that? So with set square being set on PR like this. Okay, so I will now shift it. So I will shift it to point Q here. Don't forget that I put my ruler under the set square so that the line will be parallel. Then we draw this line from Q touching this point. Touching this line, so I will call this point, so I will call it point V. So this is point V here, so I will call it point V. Okay, so this line VQ, so is parallel to PR. So it's parallel to PR. Then the next thing is that we are also going to join SP together. So we join SP or PS together like this. Okay. Then I'm going to draw a line at this point T that will touch this line SR, and that line will be parallel to SP. So how do we do that? So the way we did the first one, so I will set my set square on line SP like this, then I will shift it to point T. So then I will draw the line like this. So this line, so I call this point, I call it point U. So this line at UT, so is parallel to SP. Is parallel to SP. Let's take note of that now. So to now draw a triangle that will be equal in area to this pentagon. So this is what we do. So I will connect UP or UP together. So I will connect UP together like this. So like this straight line. So then I will also connect VP together. So like this. Okay. So this triangle, VPU or UVP, so is equal in area to the given pentagon. Is equal in area to the given pentagon. That is the first part that we need to do. Okay. Now the next thing that we are going to do is that we are going to construct a triangle, sorry, a rectangle. We have to construct a rectangle that will be equal in area to this triangle VPU. So we need to do that before we can go on and draw a square that is equal in area to the given pentagon. So we construct a rectangle that will be equal in area to this triangle. Okay, so let's go on. So what we need to do now to construct that rectangle, so what we need to do first is to draw a perpendicular line. So from we draw a vertical line from P. Okay, so a vertical line from P. So this is it from this point. So draw a vertical line to meet this line P RS, to meet this line RS. So this line is perpendicular to RS like this. Okay. So now, so we have to bisect. So let me call this point. Let me call it point M. So this point where the vertical line meets RS. So let me call it point M. So the next that we are going to do is that we are going to bisect. PM. Bisect PM. So putting the pinpoint on my compass here and extending it to this radius, I will draw an arc here. So then draw an arc here like this. So then the same radius at point M. So here I draw an arc. So here I draw an arc. So asking you to come here and draw. Okay. Now, so I'm going to draw a line. So to connect the point intersection of the arcs together. So this is it. Okay. So I'll draw a line like this. All right. So now, so what we have now, so the next thing that we are going to do is that, so I'm going to construct that rectangle that will be equal in area to this triangle. So what I need to do is that I will draw a vertical line. So I will draw a vertical line from this point V, so to meet the line. So to meet the line, so this is the vertical line at this point. And then I will also draw at U. So a vertical line at U to meet the bisector of PM. So this rectangle now, so this rectangle, so I'll call it rectangle. We have UV, so XY. So this, I will call this point, I'll call it point X, and this is point Y. So this rectangle UV XY is equal in area to this given to this rectangle to this triangle VPU. Okay. So now, so let's go and construct the square that will be equal in area to the given pentagon. So now, so I need to extend this line a little bit. Okay. So having extended the line a bit, so I put a point on my compass at this point V here and extend it to point Y here on the vertical line. Then I'm going to draw. So I will draw an arc like this. Okay. So this arc, it touches this line at this point. So I will call this point. I will call it point. Let me call it point A. So let me call it point A. So now, so we are going to bisect distance UA. So to construct a semicircle in between them. So bisect distance UA. So putting a pinpoint point on my compass here and extend it a little bit. So I'll draw an arc up here and draw an arc down here. So then the same pinpoint at A with the same radius. So I will draw an arc. So here I draw an arc here, and then I also draw an arc here. All right. So so looking at what we have here, looking at okay. All right. So Alright, so then we join the point of intersection of the arcs together. Join the point of intersection of the arcs together, so like this. Okay, so then the next thing that I'm going to do is that I put the point, let's say this point here, so I call it, let me just call it point, so let me call it point O as the center of the semicircle. So then putting a point on my compass at point O, extending it to point A here, so I can go on and draw a semicircle between A and U. So this is it. So this is semicircle. So now, having drawn this semicircle, so the next thing that I'm going to do is that I'm going to draw a vertical line. So from V, so I will extend this line VY. So I will extend line VY. So that's what I'm going to do. So I will extend line VY. So I'll just extend it. So like this. Okay. So this line VY now extended, so now meet the semicircle at this point. So I call this point, I will call it point B. So this is B. So this distance VB or BV is equal to the length of side of the square. Is equal to the length of the side of the square. So what I just need to do now, so is to complete the required square. So I put the midpoint of my compass at V. So taking this distance, so that is distance VB, which is the length of side of the square. Okay, so then I'm going to make an arc here on this line. So this point here, I will call it point D. So this point, I will call it point D. So then, so with the same radius, VB at D here. Okay, so I make an arc here. Then putting a pinpoint at B, so I make an arc here. So this is point C here. This is point C. So I'm going to connect this together. So I will connect CD together like this. Okay. Then I will connect BC together. Connect BC together like this. Okay. Then I make this a thick line. So this is the required square, whose area is equal to the area of the given pentagon. So it's as simple as I've done it. But do not forget, question B says that we should measure and state the diagonal of the square drawn in 4A Roman figure 1. So diagonal of the square. So to measure the diagonal of the square, so I will connect this point together. So connect VC together like this, or I connect BD together. I connect BD together like this. Okay, so then, so I can measure either of the two, whether I measure BD or VC. So diagonal, so BD, so diagonal, so BD, so is equal to, so I take the measurement. Okay, so I have the diagonal to be equal to 87, so 87 millimeters. So I'll just write so 87. So it's 7 plus or minus 1. So that's it. So we have answered these questions as simple as I've done it here. All you need to do is to practice. When you practice, you surely master. Thank you and God bless you.